In our last lesson, we graphed equations and we figured out where they intersected. Where they intersect are your solutions. We saw some examples where there were two solutions. We saw other examples where there might have just been one solution because they only intersected one time, or maybe they didn't intersect at all, okay? So today, we are not going to use graphs to figure out where the graphs intersect, where the lines intersect. We're going to solve it algebraically. So we're not going to be graphing today. We're going to do it algebraically. The first step is to isolate a variable in one of the equations. So guys, this y is all by itself. So that fulfills step one. You just want to make sure one of the variables is by itself. Step two, we're going to substitute one equation into the other equation. So look what I'm going to do. I'm going to write 2x plus, I'm not going to write y, equals 1. I'm going to put this equation where the y is. X squared minus 8x plus 6. Now we're going to solve. Is that okay so far? This equation has a y in it, and this equation is telling me that y is all of this. So I just put that into the equation. Okay, now we're going to solve. Let's combine like terms. 2x and negative 8x is negative 6x. I combine this and this. The parentheses aren't really important when there's a plus sign in the front, so we don't really need that. Okay, next step, I'm going to move the 1 to the other side, making it a negative 1. So what I have is x squared minus 6x plus 5 equals 0. From here, there are two things you can do to solve. You can either do an eye chart, factor it and do an eye chart, or you can use the quadratic formula. The quadratic formula works every time. So I'm going to pause here and let you guys solve using either methods. Once you are done using your method, you may look up here and check if you're correct. So on the board, I used the quadratic formula and got 5 and 1. I also did factoring and got 5 and 1. Use whichever method you like the best. Now, that was step 2. Step 2 was substitute and then solve. Now, step 3, we're going to use our current answers and we're going to use one of those equations. Let me show you what we're going to do. I'm going to write 2 plus y equals 1. I wrote this first equation down. We're substituting our answers into the original equation. So your first x value was a 5, so let's plug in 5. 2 times 5 is 10, plus y equals 1. Now subtract 10 from both sides. What is y equal to? Good, negative 9. So guys, that means the intersection is at 5, negative 9. That's one of our intersections. We found it algebraically instead of graphing today. Now let's do it again, but with this x value, 1. So I'm going to write it again, 2 times x plus y equals 1. This time I'm going to plug in my other x value, this 1. 2 times 1 is 2 plus y equals 1. Subtract 2 from both sides. What is y equal to? -1. So guys, what is the other intersection? 1, -1. So those are your 2 places where those lines intersect. A very good question was asked. I chose this top equation, but you can also choose this bottom equation to plug in your 2x values. Either one is fine. Next example. The first step, make sure one of your variables are isolated. So this one is isolated, that's perfect. So I'm going to do x minus, instead of writing a y, put parentheses. We are going to put this second equation in y's spot. That's step 1. Okay, now we're going to solve this. You have a negative on the outside, so you need to subtract every single thing in the parentheses. So this will become x minus an x squared minus a 6x and minus a 2. You are subtracting everything in the parentheses. Okay, let's combine like terms. X and -6x can be combined. So we will have x minus 6x is -5x. Minus 2 equals 8. Now, you need to bring this 8 to the other side. It will become a -8 when you do that. So we have -x squared minus 5x minus 10 equals 0. Okay, guys, you never want your leading coefficient to be negative. So what should you guys do? Good, you can divide it by a negative. So if you divide all of these by a negative, it will become x squared plus 5x plus 10 equals 0. What you did is you divided everything by a negative. You divided everything by a negative. Okay, I'm going to pause right here and let you guys solve using either method. Either do factoring or the quadratic formula. Those of you guys who tried factoring, were you able to find 2 numbers that multiply to 10 but add to 5? No, you weren't able to find any numbers. Okay, so you can't factor here. What about those of you guys who did the quadratic formula? X equals -5 plus or minus square root. 25 minus 4ac all over 2. Okay, so this will simplify to 25 minus 40 is -15. Our discriminant is negative. What happens when you have a negative under that square root symbol? You get imaginary solutions, okay? You get an imaginary solution. So your answer here, guys, is no solution. We're not dealing with imaginary stuff. The answer is no solution. So guys, a key note that you might want to write down, if the discriminant is negative, no solution. Because we are not dealing with imaginary stuff. So in this case, our discriminant was -15. Your discriminant was negative. Okay, we're going to do one more example. So guys, whenever you get your discriminant to be negative, just stop there and say no solution. I don't know what these graphs look like, but I'm assuming we have a quadratic and a linear, and they never touch. That's why it's no solution, okay? All right, let's look at this one. Now we have two quadratics. Let's see if they intersect and where. So I'm going to write, notice you have y equals and y equals, so we can just set these equal to each other. Set them equal to each other. Okay, now we just solve. So I'm going to bring this over here, make it positive. Bring the 8x over, make it a negative 8x. Bring the negative 15 over, make it a positive 15. So we're going to be left with 4x squared minus 20x plus 16 equals 0. Go ahead and solve using your method of choice. You can do factoring or the quadratic formula. No matter which method you choose, I suggest that you divide all of these by the greatest common factor. Which one would that be? Yes, you should divide all of these by 4. So you get 4 on the outside, and you're left with, well, you divided it all by 4. So you have x squared minus 5x plus 4 equals 0. Now from here, you can either factor or do the quadratic formula. You guys, what did y'all get for your solutions? Yes. You guys should have gotten 1 and 4. Is that correct? Okay, great. What did you guys do after this step? Yes, you can choose either equation to use. I'm just going to use the top one. So I'm going to plug in this 1 first. 1 squared is 1 times 3 is 3. Minus 12 plus 1 is what? Yep, negative 8. So guys, that's your first intersection. Those two quadratics will intersect at 1, negative 8. Now we're going to use the equation again. And now I'm going to plug in the other x value, which is 4. So let's plug in a 4. 4 squared is 16. 16 times 3 is 48. 12 times 4 is 48. Plus 1. 48 minus 48, that's just 0. And I get 1. Okay, so that means these intersect at 4, 1. So those are the two locations where your graphs intersect.